Okay, it's 2024012303003. So we hit a point where it's like, well, the computational cost of doing a division function with Krem annotation, just to be compliant with standard mathematics, is a very high computational cost, and it's inaccurate. So we were looking at high order algorithms to find square roots and inverses, and the inverse logically is something that would be preferable to the computation of division problems. Okay, nothing struck me right though, and I'll read what I have so far and then I'll explain where we got with it from there. So what I had written is displayed here. You can read that if you want to. So far, so good, according to current mathematics, right? It makes sense, yeah? So what we're going to do with division in Krem, and this is consistent with Krem, and the paradigm Krem is in, is we are going to look at that, and we're going to hit delete. Okay? And we're going to talk briefly about division in Krem. magically bridged and circumstances. Okay, man, I have instructive to, you did? Okay. I'm gonna do a proofread. Uh-huh. And, I'm going to start compilation of a, companion set. And just extractive of definitions which are referenced. And this will be video notes. Okay. Okay, 2024-113 Krem or Krem system. Or Krem annotation. Okay, in this application is a base unit of measure for applications related to sizing appropriate for tactile interaction by people and applications in celestial environments, and Krem system refers to a system of functional mathematics and algorithmic design used as the logical basis of range processing systems which are analog in design and are very much faster than digital computers in all complex systems applications. Range processing systems have exceedingly much quality and finesse superiority over digital systems, including the whole experience applications, whole experience applications, which may include all sensory stimuli transfers in unison, for example, experientials, which allow replayable experience records of synchronized audio-visual, tactile, sexually toned is prohibited, smell, and taste limited because it's chemically reactive in nature and differs depending on physiology and nomenclature in a specific grouping. Using a standard experiential interface specification, Krem notably offers very simple and fast musical score creation and a whole host of other applications which may be complex production tasks using common electronic or other interfaces on Earth. 3. There were several major variants of Krem, including the most common derivatives from base 10 and base 12. This definition focuses on base 12 because it's the most universally suitable and has been consolidated into a standard implementation. Base 12 was seen as convenient for cyclical or periodic applications in particular, which includes real geometric analysis, angular velocity applications like momentum differential and transfer, energetic transfer, particle physics, and celestial interaction. Base 12 was generally reserved for use in highly technical dynamic environments where Base 10 and Base 12 were mutually available depending on modular application requirements. For example, territory and contents can be mapped in base 10, but extrapolation may be more conveniently determinable using base 12 algorithmic design. Just think of the benefits and trade-offs of a Cartesian versus polar coordinate system, except in 4 dimensions: length by width by height by time, or XYZ times time, versus radius, segment, start, stop, angle, vertical, horizontal, time, or distance, segment, start, stop, heading, bearing, time, among a plethora of other cartographical representations. When considering calculation speed, in particular those using pi coefficients, trigonometric functions, vibrational translation constants, tensile torque functions, trajectories in complex tethering scenarios, and compositing realignments, among others, base 12 may make more sense, but in general base 10 is preferable. Krem base 10 is an ergonomically based standard. The main design concept in Krem is that every technical solution must be applied holistically, considering all ranges and all things of consideration are present, and that all processes have a fundamental interplay of functionality. What people on Earth would understand as mathematics is a subset prerequisite to algorithmic capability, making the study of the discipline integral to understanding Krem. In Krem, math is not a differentiated subject. It is integral to the Krem system and is approached always in functional terms. So the system design philosophy is to approach every solution as a whole system design, whether the consideration is large or small. And yeah, I'm going to take a look here. And see if we can just go to Notepad and show that and not show that. Okay. And then we'll put me, oh shit, whoops. We'll put me down here. About like that. Okay. Yeah. Just a little box in the corner. Yeah. Okay. Krem base 10 is an ergonomically based standard. The main design concept in Krem is that every technical solution must be applied holistically. Considering all ranges and all things of consideration are present, and that all processes have a fundamental interplay of functionality. What people on Earth would understand as mathematics is a subset prerequisite to algorithmic capability, making the study of discipline integral to understanding Krem. In Krem, math is not differentiated subject, it is integral to the Krem system, and is approached always in functional terms. So the system design philosophy is to approach every single solution as a whole system design, whether the consideration is large or small. The presupposition is that if a correct solution is required, the solution must be fully articulated. As a result, range processing, real instance systems are thus highly capable in working with real objects as functional input parameters in highly advanced systems. In Krem systems, Simulation is minimized in a method called extrapolation, which copies a whole system input into a controlled instance and runs a furtherance of logical component object and system interplay for projective analytical purposes, and makes a four-dimensional report generally consisting of spatial definition and time progression in all applicable composite or paradigm ranges as an output. Extrapolation is generally very accurate in advanced Krem systems, which can accurately map as finely as the fundamental level universally in this universe that is Habinabs in real time using a system called SnapMap. SnapMap relies on monitoring tether stores and fucks. And what are fucks? So such as the ones used for what is understood as gravitational linkage. Tether stores are convenient because they are accessible through the high compression layer, having no delay in the transfer or observance of change of effect. This is evidenced by gravitational observation, which at celestial scale can readily be seen to have immediate effect from one object to another, no matter how far the two are separated, as long as they reside in the same universe and have compatible fucks. SnapMap is a called military confidential system in design, although there are many approved non-military system integrations that use SnapMap, like Snap Medical. Snap Medical provides real-time, precise, non-invasive visibility into living biological and other systems, but medical care is its primary application. There are many other system integrations that use SnapMap, including gating, logistical transfer, and real intrinsic value hard currency or basis of value accounting systems. As a system of measurement, the scale that is based on the Krem as a fundamental unit of measure is also generally referred to as the Krem system. One Krem is 0.547116 1, 2, 3, 4, 5, 6, 7, 8 zeros, and then a 4 meters. Krems are grouped in 10 place value steppings separated in the middle. So would be an enclosed 5 digits, comma, 5 digits. 2 hands, yeah? The next definitive unit tier each consists of 10 place values. Place value is called a scalar span in Krem, each also having 10 increments, steppings over the previous. This makes the system ideal for people-sized applications, sizing territory, especially celestial systems, or for precision applications. It is noteworthy Krem does not rely on light years or any other velocity per time ratio as a measurement standard because light velocity is not constant over vast distances, being distorted by various aspects of the universal composite, and so is the passage of time. Krem is used on most other worlds where interstellar travel is a reality, either using high compression transfer, envelopment, or gating, both of which have the effect of instantaneous travel from point 1 to 2 by utilizing a concept understood as seaming. Seaming joins the placement of any two circumstances over a fulcrum, which can be the universal or other high compression layer. A solid configuration that acts as a core binder for a scaled containment system. For our universe, other places of principality refer to it as calm main. The high compression layer size for the universe is about 1 Krem in diameter. It is accessible using transcendental physics applications. The stepping system in Krem system measurement fundamentals is convenient to reckon with for biologicals having 5 fingers on each hand. The typical configuration for intelligent, sentient, biological, or analog individuals. Thus, the named unit stepping is not by the third power of 10, as in Earth classical numerical annotation, but the logical 10th power factor scalar, annotated as unit name NF1 in Krem, and is annotated classically on Earth as n times 10 to the ninth, or n times 10, and having an additional 10 zeros. The first power being the base of 10 and the next 9 residing in the exponent. The coefficient n is the place value, scalar span, allocation above the current scalar threshold. Traditionally in Krem implementations, the symbology is agnostic as long as the representation meaning exactly matches the standard specification, because there is a wide language and symbol distribution Krem operates in. Here it is interpreted and anglicized. The origination Krem symbol is similar to an angled bracket, but at a wider angle, about 60 degrees, so similar in view to n greater than 1. It is done here using f because this would be confused with greater than by those trained in the current mathematical paradigm. Krem does not use the concept of greater or less than. The equivalent expression is conceptualized by positively specifying the inclusive set using above and below, generally restricting the input set as a validation filter rather than the result of a functional evaluation after spending resources computing definitively disqualified results. This is algorithmically more efficient and more convenient to range processing, which is the processing standard required for advanced applications in transcendental physics, such as safely working with composite modification in medical applications. You could typify Krem as always acceptably parameterized in construction. If there is a breaking functional deficiency, it is usually solved by addressing functional range parameter acceptability or by design of a new applicable functional solution. Krem also does not use the concept of positive and negative, since 0 is considered a limit or boundary, not a number, NaN, or imaginary number. Krem instead employs signing as ascensionate. Origination Krem indicates using an up arrow similar to a caret, but we'll stick with the familiar plus, or descensionate. Origination Krem indicates using something similar to a down arrow, but we'll stick with familiar minus. Krem signs all numerical tabulations with this indication preceding the value accumulation or tabulation set. For example, of functional processing, a function fn definition would be expressed as fn set link name I1 parameter is not above, below, up from, down from, not consisting of set L1 and or inclusive x or exclusive I2 is not above, below, up from, down from, not consisting of set L2. You would evaluate using any additionally contained combinations of a function by E link name I1 descriptor L1 logical conjunction I2 descriptor L2. Any acceptable procedural description in any combination of link name I. Returning value as explicitly typed link name result or empty, further referenced as link name value or empty. Nothing or zero or no return would be delivered as a link name with an empty set, or simply as an untyped set with nothing in it, like a circle. Anglicized as 0. In Krem, this is also used as a place value holder for nothing in it, but this is different from the explicit value limit concept of 0. One has meaning in a value set and the other has no meaning because it has no value or definition. 0 and nothing are synonyms in Krem. And where link name defines this example. In the example, link name defines a functional name with no ambiguity and generally no scoping limitations. It makes it global as long as the function is in the same container as the caller. A controller is required to access any part of that which is within from any externality and is always governed by protocols of trust. A controller is required to access any port and always governed by protocols of trust. Functions would be explicitly called to operate on the parameters using an offset character, indicating the need for evaluation, thereby differentiating between a call and a typing. In Krem, this is referred to as a registration. E would create a register container of the resultant evaluation. All further references to that result use that register. Registers are ordered alongside functional definitions to increase performance in the long run. There is one aspect with logical definition and another with registry of givens, then another with solution sets. Range processing systems are extremely fast at determination and lookup because their simultaneous consideration set is vast. In other words, if that function has been done using a specific input, it has a given solution from then forward. If the function is revised, the solution set is built again on redefinition. The difference, diff, of each set is recorded as a rollback history, and the general approach is to review any functional discrepancies which may indicate current or past flaws in understanding or assumptions. This does not make Krem an assumption-based system. Rather, a design aspect and approach to Krem is to routinely perform integrity and consistency auditing of all functions and registers, even those with long-standing stability or consistency in usage. Krem seeks to match actual conditions as closely as possible in all things. A popular Krem design approach is to typify all components functionally as containers, thereby enabling definitive persistence and concurrency in all considerations almost simultaneously. Krem also employs framing, a concept that completes all enclosed system container state definitions in one pulse and indexes it by serialization. This provides a very thorough audit path for all considerations of a system at all times. Compression is employed to set the frame index base, then only record differences from there forward. Periodically, a keyframe is generated that records all aspects, and everything between keyframes relies on compression differentials. This maximizes Krem systems in many aspects, including having a very high degree of fault tolerance and enables very high processing capability. So, the function would be called for evaluation using special evaluation function E. E link name I descriptor L1 conjunction I2 descriptor L2. And if the equivalent to setting a variable would be desirable, it would be indicated as either a functional evaluation or explicit definition with functional typing explicitly indicated in a special assignment function A, which creates a new register. A new link name is link name parameter set, or a new link name is E link name I1 descriptor L1 conjunction I2 descriptor L2, which effectively creates a pointer having a new name to a register of a previous functional return. In Krem, this is called a proxy and is afterward referenced using a special proxy function indicator P. This is E accumulate whole I1 up from 1 and I2 down from 100. That is E invert I1 is P this. E display P that would display and we would not use invert. Say multiply I1 is P this. Krem 500. 25250 and then 9 zeros. And that would be a tech room. Would display one tech room that display a something else is Krem decimal negative 13.3274. Would display and assign the value to the link name. So something else would display the name of it, something else typed as following value negative Krem 13 and Techrum over the fulcrum Techrum 32740 5 zeros. So, to explain a little more about the notation used in the description above, I1 over 2, I1 or 2 is the functional evaluation subject boundary definitions, which like a variable substitutes all values contained in L1 and L2 to produce the set return value or range. Is sets I1 or I2 to L1 or L2 literally, respectively. Preceding is with not creates a new set definition without that specific value. Above is values greater than exclusionary. Below is values less than exclusionary. Up from is values greater than and including. So we'll do this. Is above, below, up from, down from, consisting of set, L1, and or XOR evaluate So to explain a little more about the notation used in the descriptions above, I12 is the functional evaluation subject boundary definitions, which like a variable substitutes all values contained in L1 and L2 to produce the set return value or range. is sets I1 and I1 or I2 to L1 or L2 literally, respectively. Proceeding is with not creates a new set definition without that specific value. Above is values greater than exclusionary, below is values less than exclusionary, up from is values greater than and including, down from is values less than and including. Consisting of set is a discretely defined collection of inputs generally accumulated and named using a name set FNI. It is noteworthy I could be a range or collection of resultant evaluations or explicitly defined values, and accumulation of additional items is generally done in one range definition, not a procedural walkthrough, which is far superior to binary systems where expressions have to be evaluated one at a time. Proceeding this with not behaves the same as described after is. L1 is the functional parameter to be evaluated, and L2 is the second, L2 being optional. However, omission assumes natural or defined numerical limitations which exist in all systems and reality. There are generally only two parameters per functional evaluation because there is in logical evaluation generally two limitations for input under any given consideration at a time: a minimum, a maximum, or a range set, whether explicitly defined or a span. And indicates a concatenation of sets L1 and L2, or indicates both sets L1 and L2 are acceptable. XOR indicates set L1 should be differentiated in results from set L2, and the returning value is a twofold return set, link name revert return value set, and one XOR return value set return value or set and 1, or return value or set and 2 XOR, and it is logically only acceptable to use one or the other, not both. In further evaluations, such as the case required to successfully evaluate roots without relying on undefined substitution values like imaginary numbers. We don't fuck with that because we don't have to. Evaluate is implied. The returning value is always thereafter referenced with the fundamental name, or the functional name, the link name preceding it for system integrity purposes. In Krem, the entire functional value returned would be surrounded by an ellipse, not parentheses. Parentheses are the nearest anglicized equivalent. In range processing systems, there are generally not predetermined type definitions except those employed using base toolkits, loosely translated as constructions and modules and frameworks in more capable systems of speech. Because this limits the functional capability of algorithmic implementations, the approximate equivalent is, therefore, to tag all functional returns with the generating function, which allows very apparent and comprehensive tracing of algorithmic failures and state in a single clearly articulable set, which may be passed again as a parameter to other range processing systems. Recursion, lambda, self-reference within self of a functional definition is explicitly illegal in this system. The logical equivalent is to use parent-child functions, and if a child becomes a parent, there is an additional set of redefinition which copies the child definition into a parent in recognition that something cannot be considered as the result of itself. The reason this is the way it is, the reason this is this way is because recursion leads reliably to total system failure in a range processing system, which is constructed of analog components. It may have a digital subset, but does not rely on it for primary functionality. Range processing systems are generally extremely faster than digital ones, utilizing the same share of resources to construct. Therefore, the Krem system implementations tend to avoid digital implementations outside of discrete functional needs. Recursive application is distinctly different from iterative application, that is, repeating a functional approach on the resultant of the same function. Iteration is an externalized approach consistent with incrementalism, discussed later, and recursion is internalized. The function calling on itself and passing its own result into itself again for evaluation. It may seem the two achieve functionally the same result, however, in real consideration, recursion breaks down and iteration doesn't. It is also understood in places using Krem that the employment of recursion in solution candidates was originated as an attempt to prove capability in producing something functionally, taking nothing as an input, as in an uninterrupted lambda or circular reference. An application of this concept can be used to produce fuck breakdowns, more commonly known as black holes. This process seams the fuck into itself, which has an effect similar to holding two mirrors up to each other, except if the result was that the mirror fit into the boundaries of its reflection as fast as it reflected. It breaks the containment integrity, fundamentally leading to a massive energetic discharge and plasmatic burn-off along the axis of subfuck singularity. This is also commonly known as depatterning out, wipeout, if it's an accident in a vehicular travel, or getting silly stringed if it happens to a person in gating applications. Furthermore, if this condition is achieved in all paradigms, the individual is said to have been disorganized, which is essentially destroyed unrecoverably. This happens because the integral fuck resiliency is approaching infinitely compressed in one frame as its available spatial containment allocation is reduced to that approaching the elemental tether store configuration maximum it attaches to in the high compression layer, which is nearly singular in ratio when compared to the universe it binds. Notably, Nimrod was said to have employed a recursive draw snare in his projectile designed to kill God. It also consisted of other complementary mechanisms and had a gated envelope delivery system. The weapon was designed using a Krem system derivative explicitly purposed for the attempt, with very high popular participation, in retaliation for and to try and avoid another retribution like the flood, which was almost universally experienced in various degrees of severity. It has been supposed that the high compression layer was used as the fundamental lever to achieve the flood, although it was not understood where the introductive energetic and massive transaction originated. One theory was that God has application using an inversion lambda, but without lambda solution, this is not attainable. Lambda solution is the condition that yields the most primary possible subfuck configuration, even below basic, used commonly in all fuck construction for both store and conduit. It is widely supposed the key to understanding creation is in attainment of stable utilization of lambda solution and its inverse function, but Krem specifically avoids trying for this solution because its purpose is in handling all that which exists organizationally, not explaining how to make something out of nothing organized. Krem is quite intentionally flagged as order begets order. The perverse Krem system, called Kevlek, is generally flagged as order from chaos. Disagreements between the two schools of thought, objectives, purposes, intentionalities, and efforts have led to many very serious wars. One is submissive to God, and the other opposes or attempts to surpass God, depending on the school. It was said Michael originally chaired one and Satan the other. Krem was a man of old and of great renown in the third generation after Michael, who is also known as Adam in this composite set, which includes physicality. Satan also has no inclusion in physicality and no name in it either. Everyone and everything must and does have a name for each composite family included in their whole composite being. That is the reference which identifies that particular configuration or identity within the composite family. On Earth, these viewpoints are generally rejected flat out, but in many places utilizing Krem, there are individuals old enough to remember the times in which some of these events occurred. They are called primary witnesses and are still in good health. There are also others which are not of this series at all. Continuing the explanation of Krem as a measurement system, each group of 5 place values, scalar spans, is offset by a comma, and the naming incrementalization is tiered by the logical 10th power factor scalar, annotated in Krem as NF1, Earth's expression as n times 10 to the 9th, or n times 10 with 10 zeros, and each uniquely named basic measurement standard is an NF1 factor over the last. Logically, each additional logical 10th power factor scalar adds 10 more place values, scalar spans to the number n, so NF2 is expressed as n times 10 to the 19th, n times 20 zeros, adding 20 place values or scalar spans. For clean functional tabulation, numerical values in Krem are always expressed in grouping sets of 10 scalar spans only, each 5 separated by a comma. Origination Krem uses a backslash, so 5/5 in other systems. Extrapolated for scale, this enables figures to be neatly handled as rows in sets rather than the run-on condition found in decimal systems, unless precision is sacrificed. Math without precision is moot in real applications. Krem-based systems are also made to be digitally character agnostic. As long as there are 10 digits and an equivalency function, a localized group may use the language set suitable to them. This makes Krem very easy to adopt and highly portable using Tremania. For example, the basic tiering implementation of the Krem system of measurement follows: 1 F1 Krems is 1 tecrum, 1 F1 tecrums is 1 torcrum, 1 F1 torcrums is 1 kilcrum, 1 F1 kilcrums is 1 shukram, 1 F1 shukrams is 1 hulcrum, 1 F1 hulcrums is 1 nucrum, 1 F1 nucrums is 1 mellicrum, 1 F1 mellicrums is 1 vecrum, 1 F1 vecrums is 1 felcrum, 1 F1 felcrums is 1 lacrum. So 1 lacrum is 1 Krem F10 and 1 hulcrum is 1 Krem F5. To combine measurement standards for precision, one would annotate from largest to smallest using tabulation. Thus, considering the sum 913546697805321458222132174358666777114258666678288819798183881979818389197998183891959 703060910120151611220452602830199966 Krems would be annotated as a tabulation set range span, largest to smallest, the whole set enclosed in an ellipse and preceded by a directional character indicating ascensionate or descensionate. Every row in the tabulation has 10 scalar spans, place values, always. Do you have Lakrum? 91354 69780. Felkrum 54321 45822. Vekrum 13217 43518. Malikrum 08012 67771. Nilkrum 14258 66678. Hulkrum 28881 97981. Shekrum 83891 95970. Kelkrum 30609 10120. Torkrum 15161 17210. Tekrum 12345 24260. Krem 28301 99966. Depending on the application, it may be convenient to express the whole set relative to a single unit specification, so the above set could also be stated as all Krem positive scaled by functional F1 through F10. The base ones does not have a 10th power scalar, man. Blah da 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 da. Do you think that's a good? Do you think I've read this enough? Instructed, continue. White one. Krem uses the idea of leverage or a fulcrum for values between 0 and 1. 0 is an unattainable limit, undefined, or imaginary number in Krem. The commonly taught aspect describing the distance between 0 and 1 is that it is a scalar in its best application, which is very useful in transcendental physics applications. The fulcrum is the limit approaching 1 from 0, such that 1 is unattainable, or it would be 1. The reason this limit is called the fulcrum is that it defines the boundary between natural reckoning and the key application of values between 1 and 0, which is fractional relative to spans greater than or equal to 1. Which is a precision scalar relative to spans greater than or equal to 1. Since Krem validates acceptable input ranges in all applications, this in-between scalar component to a number is usually dropped by virtue of the definition of the elemental fundamentals in a function. Rounding is never used. That is, in real things, you either have a whole one or you don't. Range functions do not ever assume partials of wholes are possible, even if the thing in question is to be divided into an intact elemental component set. This yields much more accurate results in all real applications. Scientific applications. Krem-based societies do not call technical academic applications science. They call it, roughly translated, as natural capability. This situation yields one or more component elements which are each a whole of its own type, not the parent containment conglomerate type. Thus, it cannot rightly be called a fraction of the parent. Scalars applied as proportionalities are extremely useful in ultra-high precision applications like those using the high compression layer. Where it is noteworthy, every elemental component must have a one-to-one pairing conduit at a seam to safely use it. The high compression layer is seemingly paradoxical because it has the actual size of about 1 Krem in diameter, but all things contained in the calm main universe are anchored to it, so it has the effective size of the universe in transcendental applications. The net result of having capability to access this layer yields instantaneous access to any universal component, which allows immediate point-to-point transfer applications and travel. Range processing systems are required to minimally support safety in even basic applications. Digital computers do not have enough capability, even at their current maximum configurations achieved. One current application Earth 3 is starting to see this evident is in quantum computing applications, but these have high danger potential in the currently unmanaged pairing attempts, entanglement. Individuals monitoring progress here and other places have concerns about the emergence of this and other technologies being tried on Earth 3 for precision or to indicate a fractional set. One would annotate thus, considering point 91354699780121458222132141279182134526609101201542402830199660 Krems would be annotated as a tabulation set range span, largest to smallest. The entire enclosed in ellipse proceeded with a direction and fulcrum character, similar to an A anglicized equivalent to period, which separates whole from partial. The fulcrum A indicates the highest stepping. Below it starts with the inverse of 1f1, which is 1 over 1f1, or point 9 zeros and a 1. It is or 9 zeros after as an implied reciprocal scalar for each diminishing row. Precision scalar for each diminishing row. In the Krem system, it is understood that this partial is a scalar application to a whole and can be useful in conversion or differential applications, both theoretical and actual. The unit of measure applied also corresponds to distance from the fulcrum with the implied offset scalar, and the incrementalization of naming applications is also increasingly dissentient. In other words, you could name it downward. Yeah. When you max out your primaries, you additionally functionally 10th power scalar those downward. So F1, F2, F3 as this. So if you were to just stick with Krem, fulcrum, so this is less than 1, dissentient. In precision anyway. Noting that when expressed below the fulcrum, the 10th logical power factor scalar value is inverted 1 over 1 Fn. The 10th logical power factor scalar is at a rate of 1 to 1 Fn. For Krem systems, it is not commonly the case values are tabulated with fractional components at all. This is because Krem uses a concept known as appropriate resolution. That is, if you are expressing a value, use the one allowing expression in whole units or trim the resultant to whole units. The fulcrum A is generally only used in conversion or assertion of proportionalities. Conversion precision or proportionalities, which are then resolved using appropriate resolution. So to represent a sum of precision in one tabulation, one would indicate it thus. Considering the sum would be tabled in a mixed annotation as follows, the whole set enclosed in an ellipse. Or can these mean exactly the same value? Considering the sums in the series 0.12345 Krem, negative 12345, 6.67890 Krem, and 21 Tekrem, one would indicate the set as follows: the elements separated by a horizontal line across the width or a vertical spanning the height of the elemental annotation. Also noting the origination Krem representation would encircle each whole element in addition to the grouping. So these are three elemental values here. Okay, positive, fulcrum, Krem. This would be Tekrem. Yeah, it's exactly fucking opposite in there. Tekrem 1, 2, 3, 4, 5. Krem 1, 2, 3, 4, 5. Tekrem 6, 7, 8, 9, 0. Tekrem 21. Okay. And that's missing a positive. Okay, but what about values in excess of the representation increment Lakerum? There are additional name steppings beyond this every 10th logical 10th power factor scalar, beginning with Lakerum 1f10. That is 1 times 10 to the 99th Lakerums equals n times a whole fuckload of zeros Lakerums. Three, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 100, 93, 96, 99, 100. Hundred zeros. So a lacrum 1F10 is a morelacrum. A morelacrum 1F10 is a chylacrum. A chylacrum 1F10 is a derelacrum. A derelacrum is a ferrolacrum. A ferrolacrum is a camulacrum. A camulacrum is a shinulacrum. A shinulacrum is a vanulacrum. A vanulacrum is a lelylacrum. A lelylacrum is a delylacrum. 1F10s, yeah, blah, 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 blah. Delylacrum 1F10 is a chymolacrum. And the next 10, a chymolacrum 1F10 is a delychymolacrum. A delychymolacrum is a vechicrum. A vechicrum is a shellicrum. A shellicrum is a mechlocrum. A mechlocrum is a homilocrum. A homilocrum is a toplocrum. A toplocrum is a yeclocrum. A yeclocrum is a perlocrum. A perlocrum is a camerocrum, and a camerocrum is a lacrocrum. A lacrocrum. In places using Krem, the general rule is, 1F10s on all of those, of course. The general rule is there are no more than 10 steppings. Tabulation rows difference between named steppings. There are many more steppings, but outside specific applications, they are not used. These higher scale measurement spans are very important in large scale systematic extrapolation in particular. Just for comparison, lecrocum is Krem 1F200, 1F200, which is equal in meters to 5.47116 bunch of zeros E with 2,000 zeros after that. The Milky Way galaxy at NASA estimates is approximately 9.5 times 10 to the 20th meters. That is about positive torcrum 17, tacrum 36377, 66031, Krem 33400, 5 zeros. Hoag's object, some estimate, is 600 million light years away. That is about plus 1 torcrum 0.000103752, tacrum 0.065863260. Larger scale measurements are useful in cluster management considerations. A cluster is a grouping of what would be called galaxies here, both that which is consisting of both that which is dark and illuminated. The tabulation system is not limited to measurement of distances, but can be used for very large economic and trade considerations, such as in enumeration by atomic stable atom transactions with precious metals. Krem system application philosophy for analog range system. Incrementalism. Krem employs the chief strategy of incrementalism in all things. Since the functional design approach is always default holistic, the functional design methodology seeks to address all known factors in all things pertaining to the object of functional analysis. Having all functions designed this way yields a mesh network of functional analytics with support for all known consideration in all avenues of inquiry. For example, on Earth, one would approach a problem like an object in free fall as if it was in a vacuum and all there was to consider was mass acceleration resultant from gravity, maybe with a hard limit. In the Krem system, the analysis would not take place outside an understanding of all aspects of it. Object specification, which would include tethering, attractive linkage flows, and composition, internalities, interfacing, layer geometry, topology, and energetic population in each interactive specification. Each interactive specification, anything each interactive that object. So each interactive with that object specification, same considerations as object specification for each. Distortion thresholds, which include energetic overload leading to geometric compromise or composite continuity breakdown. Shearing thresholds, current frame, breach, shatter, stretch, snap, and radiographic influences generally affecting energetic population but may have extended effects in overload considerations. Posing the question, most people would assume the situation is that the object in free fall was moving toward Earth, but what if it was toward the Sun? In Krem-reliant populations, it is a failed consideration without full context and interactive specificity. The system employed the systems employed there make this a matter of fact for most considerations, and specialists designing further specification completely adhere to a holistic approach. That makes these systems extremely durable. Incrementalism sets the span of consideration to a range of progression and envelops the whole consideration for that range into a frame. Functions are tuned to solve for a framed consideration or an accumulation of framed considerations to produce an aggregated solution to an inquiry. So for every consideration, there are 3 stages: initial, differential, and final. An aggregate solution would accumulate finals given an initialization, an incremental span, and a range. Frames would generally be tuned to align with spans and ranges, thereby containing all things within that increment. This way, the whole system can be set to a standard periodical view of state, and it is possible to construct a view that contains frames having views in them. Essentially, this enables up to full system encapsulation in real time, consistent with a container or controller, depending on the specific solution set. That kind of segues into band processing. Band processing is the approach that specifies ranges of views which can be handled concurrently. Essentially, it defines a band capable of handling a range of holes in equivalent sizing and graduates the handling of all views sized in that particular band. Basic mathematical functions. Consistent with these approaches, there are a few approaches to regular issues one would find in most systematic analysis. Addition is an inherently ascensionate concern. No duh, right? Therefore, you'd start with the most fundamental band and work upward. To evaluate the basic addition consideration, 91354697805432144582213891979881959703060091122015512426028301996 Krem's plus 9135466 same Krems. You'd annotate the whole consideration before evaluation. Accumulate this annotation. So you would have the accumulation function calling each distinct encapsulation of that definition with unit and sign. Elemental separation, encapsulation of the whole. Post-evaluation, if expressed as initialization, differential, final. Otherwise, the functional return would be valued at only the third column. Accumulate, this was the 3 elements of consideration. So this would be L1, L2, and then resultant, which is graduated 1 over these. Noting that band processing would generally consist of only 10 subranges, so the top value 00000 000 0, 1, F11 would be graduated to the next band. Subtraction. Subtraction in Krem is also handled as accumulation with consideration to whether the figure group is ascensionate or descensionate. All figure groups are signed, so you technically wouldn't subtract, you'd accumulate, and sign ascensionate or descensionate, positive or negative, respectively, would indicate the interaction set the function would use in the accumulation. If the two figure groups are evenly ascensionate and descensionate, the net is, of course, nothing. Remember, in Krem, the numerical consideration is all natural numbers, which may act similar to integers with additional precision depending on the scale. The general handling of precision, that portion of the value between 0 and 1, is to adjust to the basic whole unit of measure applicable to the situation. Generally, in Krem systems, the application of values between 0 and 1 is as a reductive scalar coefficient of the whole, such as in proportionality adjustment. In such considerations, the whole situation is often evaluated and the scalar adjustment applied last. Since Krem systems tend to evaluate to only keeping the whole functional result, the precision in a final evaluation is usually trimmed off rather than rounded. It is more accurate than in handling with real things. Prepended to the differential, you'd evaluate the relationship between the two of opposing signs. If the first and second figure groups are respectively negative dissensionate and positive ascensionate, or positive ascensionate and negative dissensionate, then you'd compare the absolute value of each and begin the accumulation with the greater first. Then subtract value group 2 from value group 1. The overall sign after evaluation is the original one on the greater absolute value prior to using the absolute value for comparison. If both figure groups are negative or dissensionate, then you'd add the absolute value of both and keep the sign. Like addition, you'd start from the lowest order and work upward. The difference for subtraction is that if the second value in the comparison doesn't satisfy the first band, the next highest order hands down a value of 1 in its band to complete the computation. This is a reliable approach since the operation is always ordered absolute value greater minus absolute value lesser, then taking the sign of the greater for final figure group. So, to evaluate the basic subtraction consideration, this whole number minus this one, both in Krems, you'd annotate the whole consideration before E, evaluation, in an accumulation function here, element 1, element 2. Then the function, prior to processing, would functionally reorder it as accumulate. It would send the absolute value lesser to element 2, subtract. Post-evaluation, if expressed as initialization differential final, otherwise the final functional return would be valued at only the third column. The sign of the first value is carried. So in other words, this is greater and it's negative. Subtracting a lesser positive yields a negative. Yeah? Okay. Good luck getting a spreadsheet to do that and give you the actual total. This is 110 digits. One number. Oh, sorry, 120. Sorry, I got dumb for a second there. Good luck getting a spreadsheet to do that and give you an actual total, man. Multiplication. Multiplication is approached as a two-stage function. The base digitization is multiplied and the overflow is accumulated. If either figure group has a dissensionate negative sign, the whole resultant final is dissensionate. If both figure groups have dissensionate negative signs, the whole resultant figure group is ascensionate positive. Of course, both figure groups, if ascensionate positive, yield an ascensionate positive result. for the computation, the sign is ignored because it's factored out definitively by the Krem standard articulation. What does that mean? That means that your fucking sign precedes the value. It's always held separately, man. Very explicitly, very clearly shown. Blah 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 da 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 da. Should I leave it at that, man? No, I don't think he was kidding, man. But I am going to cut my hair, and I'm going to clean up, and I'm going to look better. Okay. Okay. That's a setup, man.